Hello, this is Mr. Collier, and today we're looking at continuous and differentiable functions. Okay, the first function we're going to look at is y equals absolute value of x. And the graph looks like this here, like a V shape. And a function is continuous if you can draw it without lifting your pen off the paper. Okay, and we can with the absolute value function. There's no asymptotes, there's no holes, there's no jump discontinuities. So it is continuous. And we look at this one here. Well, right away I can tell it's not going to be continuous because it's not defined at x equals 1. So there's going to be a discontinuity there. And if we look at the point x equals 1 is also discontinuous there. Because if you plug in for this section right here, if we plug in -1, we get -2 times -1 minus 6 equals -4. And if we plug in -2 into this one here, we get 2. Okay, so we plug in -2 squared. It's 2 times 2 minus 3 over x minus 1. We get a 2. And the actual value at x equals 1 is 2. So 2 of these are matching, but this one here doesn't match. So it is not continuous. Okay, this means basically the function goes like there's a straight line. And at x equals 1 we have it drops down to, or it goes up to 2, and then this is also like a straight line, and at x equals 1 we have a discontinuity. Anyway, there's going to be a discontinuity at x equals 1 and at x equals -1. Okay, so a function is differentiable if it's continuous at x equals a, so it's differentiable at x equals a if it's continuous at that point, and if this is if the left derivative equals the derivative on the right. Okay, sometimes you have to go back to first principles to find this derivative. Using the graph, explain why it's not differentiable. Well, the graph of this is cube root of x minus 1. So it's going to look like this and go through x equals 1. And if you notice, actually I didn't draw that so great, but right in the middle at x equals 1, the slope of the tangent is undefined. Okay, so that means the derivative is undefined at x equals 1. Okay, so the derivative is undefined at x equals 1, therefore not differentiable. Okay, if we look at absolute value of x at x equals 0, well, if you think about it, you cannot draw one tangent line at that point. Okay, because it's a sharp point, there's like an infinite number of tangent lines you can draw, so therefore there cannot be a derivative there, right? So if you have a sharp point like that, it's going to be not differentiable. Okay, as a matter of fact, if you find a derivative from the left and a derivative from the right, they are not equal to each other. One's going to give you the slope of this line, and one's going to give you the slope of this line. So it's going to be -1 and 1, so they're not equal to each other. Therefore, it's not differentiable at that point. Okay, here's a common question that comes up. Find a and b such that this is differentiable for all x greater than 0. So first of all, if it's differentiable, it has to be continuous at every point. So that means that if I plug in 3 into this and this, they should be the same. So ln 3 has to be equal to 3a plus b. And if it's differentiable, then the derivative evaluated at x equals 3 of ln x has to be equal to the derivative evaluated at x equals 3 of ax plus b. So that means 1 over x evaluated at 3. Let's write it like this. Evaluated at x equals 3 has to be equal to, a. Evaluated at x equals 3. There's no x for that part, so it's just 1 over 3 equals a. So we have the a value already, and just plug it in over here. So ln 3 equals 3 times 1/3 plus b. So b equals -1 plus ln 3.